Let's take a look at the perimeter of polygons. All right, so remember the perimeter of a polygon is the sum of all of the lengths of the sides. And so if we look at this square here, we know that a square has all equal sides. So if one side is 8, then each other side is 8. So to find the perimeter, we could simply add 8 plus 8 plus 8 plus 8 to get 32, or we can multiply 4 times 8. So again, perimeter is just adding all of the sides of a polygon. All right, so let's take a look at this example here. It says below is the diagram of a garden. Shelley would like to put a hedge of rose bushes around the perimeter of the garden. All right. What is the length of the hedge of the rose bushes round to the nearest tenth? So again, we want to find the perimeter of this figure, except we have two figures here that we can break the hedge or this garden up into. So I put a line here so we could break it up into a rectangle and a triangle. So here we have 4, 12, and we know the opposite sides of a rectangle are congruent. So this side would also be 4. And we have a congruence marks right here. All right. So if we have a congruence marks here, we have another one right here. Well, you can see it. So that's telling me that these two sides are congruent. So this little piece here is 4. All right. And this piece here is also 4 because it has that same congruence mark. And so the only thing we need to find now is the side length of the triangle because we have all sides of the rectangle, but we need to find the length of the hypotenuse of this triangle. And I know that this is the hypotenuse because if this is a right angle right here, then this would also be a right angle. And remember, the hypotenuse is always opposite the right angle. So this is the hypotenuse, all right? And 4 is a leg. Do I have the other leg? Well, yes, I do, because if this is 4 and the length of the entire rectangle is 12, then I know that the length of this side would be 8, because 4 plus 8 gives me 12, or I could simply subtract 4 from 12 to get 8. So I have my two legs of this right triangle, and I could use what theorem? Well, I could use the Pythagorean theorem to find the missing side. So remember, if you have a right triangle and you have two sides, you can always use the Pythagorean theorem to find that third side. So in this case, I'm finding the hypotenuse. So remember the Pythagorean theorem, I'm writing it right here. A and B are my legs. So here's a different color. So A and B, 4 and 8. Again, I could put A for 4 and B would be 8. Either way, I could switch it up. It doesn't matter. They're both legs. But 8 squared plus 4 squared is x squared. I could put C. I can use any variable because I know that I'm looking for the hypotenuse, which is equal to these two sides here. So just simplifying that, 64 plus 16 equals x squared, and I get 80 equals x squared. Take the square root, and that is about 8.9. So I found the length of this side would be 8.9 approximately. So now I have the outer lengths of every side here, so I simply want to just add them. So kind of drew my work over it, but it says here to add all of the exterior sides to find the sum. So let me just do this so it's not all messy. I had square root of 80 and 8.9 is x. All right, so I want to add all my sides, and so 4 plus 4 plus 4 plus 4. So I have 4, 4, 4, 1, 2, 3, another 4. So I have 4 4s, right? And I have a 12, and I have that 8.9. So I'm adding all of my sides together. So double check. I circle each side to make sure I added each one. So that includes all of my sides, and so adding those sides together, I get the 36.9 feet. Alright, so let's take a look at this example here. It says find a perimeter of polygon house, or House. So first, just like the previous one, we need to break it up into different shapes. And so I could start out by drawing a line here, because I know that that is a rectangle. There it's on the grid. So each side is, this is 3. I'm just counting the spaces. 1, 2, 3. Counting the spaces at the bottom here. 1, 2, 3, 4, 5, 6. So this is 6. All right. So I have the triangle at the top here, EHO, but it's not a right triangle. Okay, so I need to break this triangle EHO into 2 separate triangles here. So I'm going to draw a line right here. Okay, so that's one triangle, and then this would be a triangle. So I will have 2 separate triangles. This smaller one here, so this side here is 2, and I have a side length of 1. So I need to find the length of HO. That would be the hypotenuse, because where these lines intersect, it would be a right angle. This is perpendicular. And so I could find HO by using the Pythagorean Theorem. So finding HO, or OH. Alright, so remember Pythagorean Theorem. So that would be 1 squared plus 2 squared is equal to, I'm going to say C squared. And 1 plus 4 is equal to C squared. And I'm left with the square root of 5 here. And that is approximately 2.24 for C. Alright. Equals C. Next, I want to find EH. So that's also the hypotenuse here. So this length here, I already have it, is 2. If this side is 1, this will have to be 5. I could just count the spaces, 1, 2, 3, 4, 5, or I could subtract 1 from 6. Doesn't matter. So to find EH, same thing. I'm finding a hypotenuse. So these are sides A and B. Okay. And 2 squared plus 5 squared is equal to, I'm going to call this C squared as well. So 4 plus 25 is equal to C squared. Just simplifying this equation here. So the square root of 29 is 5.39. So I found the length of this side is 5.39. And the length of this side here, which is what I found for HO, 2.24. So I'm just going to add all of my sides together. So perimeter of the house, so SE is 3 plus EH, just going around here, 5.39 plus HO, 2.24, plus OU, that is 3, and plus US, that is 6. Excuse my handwriting here. So I'm just going to add up 3 plus 5.39 plus 2.24 plus 3 plus 6, and that is going to give me approximately 19.63 units. So the perimeter of this figure here is approximately 19.63 units. Alright, so let's take a look at this example here. We have a regular pentagon, and we want to find a perimeter and give the exact answer. We notice here that we have lots of decimals for our ordered pairs on the grid, but we're not going to need those because this is a regular polygon, in particular a regular pentagon. And what do we know about regular polygons? Well, all sides and angles are congruent. So if we just find the length of one side of this pentagon, we could simply multiply that side by 5 or add it together 5 times. All right. So what we could do, we could either use the distance formula or the Pythagorean theorem. I'm going to show you both, and you just choose which is easier for you. And we're going to find the length of one side and add them together. All right. So first I'm going to use the distance formula, and I'm going to actually choose these two ordered pairs, because as you can see that they are whole numbers and it's a lot easier to work with. All right. Labeling this x1, y1, x2, y2. Plugging it into the distance formula here. That would be 2 minus 4. So x2 minus x1 plus 3 minus 4 squared. Simplifying that. 2 minus 4 is negative 2. Negative 2 squared would be positive 4. Plus 3 minus 4 is negative 1. Negative 1 squared would be positive 1. And simplifying that a little more, d would be the square root of 5. So I'm actually going to leave it under the radical because it says give the exact answer, so no decimals here. So we know that one side is the square root of 5. But just to show you that if you use Pythagorean theorem, you're going to get the same answer. And you just choose what method you prefer. So if I draw a line here and here, I can make this a right triangle. This length would be from 3 to 4, so that would just be 1. From here to here, this would just be 2. So I would be finding the leg. So I should get the square root of 5. 1 squared plus 2 squared equals c squared. 1 plus 4 equals c squared. I get 5 equals c squared, and I do get the same answer. So either way, you're going to get the square root of 5. All right. And so now, since I know that one side is the square root of 5, I could simply add all of the sides together because they are all congruent, or multiply by the length. All right. So the square root of 5 plus the square root of 5 plus the square root of 5. Instead of doing that, I'm just going to multiply by 5. All right. Here we go. And the perimeter equals 5 times the square root of 5. And that is just 5 times the square root of 5. Because if I add the square root of 5 5 times, it would be an understood 1 in front right here. And I would just add. All right. And so my answer for the perimeter of this problem is 5 square root of 5. I would like for you to try this problem on your own. You could either use the Pythagorean theorem or the distance formula to find the length of one side to get the perimeter of this regular hexagon. So go ahead and pause the video and try this problem on your own. The answer you should have gotten was 12 square root of 2, or 12 times the square root of 2. I used the Pythagorean theorem, and so right here I drew my triangle, and each of my sides were 2, so I found the hypotenuse, which was the square root of 8, and we could actually write that in simplest radical form, break that up into 2 factors, 4 times 2, and take the square root of my perfect square, which was 4. So the length of this side here was 2 square root of 2. And then I could simply multiply that by 6 because the hexagon has 6 sides. Or I could add all of the sides together. But either way, you should have gotten 12 square root of 2. If you did not, analyze my work a little bit more. Pause the video and try to see why you didn't get it correct if you didn't. So we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are Introduction to the Area of Polygons and Area of Polygons using Coordinates and Trigonometry. If you haven't already, please like, comment, share, and subscribe. And again, I want to thank you for learning with me.